Welcome back everybody, this is the Crystal Clear Electronics video series 3rd chapter and 2nd part. As we promised, we move on with showing you the components and symbols.
Let's start with resistors, who, surprisingly, most often exploit the essential property of having a resistance. It's worth thinking about it. For example, a simple voltage divider can be built from several resistors, where the amount of division depends on the value of the resistors. You will see an example of this in the 5th video. As current flows through the resistors, heat is generated. In some cases, this can be useful, for example, when you want to dissipate energy from a battery by converting it into heat, or in the heaters of a heating system. That is why a wide variety of resistors of different values and designs exist. We have listed some of them on the table. When we get to know some of these types, let's start with a simple illustrative example from the lesson. The example is simplified, but it will help you gain a better understanding. A resistor can be imagined as a pipe whose interior is not completely empty, but full of obstacles. When current flows through the resistor, then some of the electrons passing through collide with the obstacles in the pipe, and after the collision, they move slower. When the collision occurs, a sudden change in the kinetic energy of electrons creates heat, which warms the resistance. You will experience this when you try it. If we force too much current through the resistor, then a lot of electrons will collide, and it may generate a huge amount of heat, which may cause the resistor to burn. Each resistor has a parameter which shows how much electrical power it can absorb without damage at a given ambient temperature. If it is exceeded, then the resistor can warm up so much that it will cause permanent damage in its material. Based on the example, the IEC symbol can be imagined as a figure of a pipe viewed from the top. You can see the ANSI symbol of the resistor on the right side of figure 14, which is similar to a wire-bound resistor and can be made by winding any insulated wire. But how? If we know the specific electrical resistance of the material, then, depending on the length and cross-sectional area of the winded material, any resistance value can be created. The conductor's resistance is directly proportional to its length and inversely proportional to its cross-section. Resistors could not only be made by winding a wire, but for example for SMD resistors, also from coating an insulator material, like ceramics, with metal or carbon layers.
Gergely, I think it is important to point out here that on wiring diagrams the values of components are usually given without measurement units, using the SI prefixes shown in the revision of basic mathematics video. The absence of units of measurement is not a problem, since the symbols in the drawing clearly identify the parts, so the units of measurements are given. This is fortunate because it avoids the need to unnecessarily write the unit of measurement after each value.
Yes, there's a good summary table in the curriculum. Let's check it out. The measurement unit of resistance is ohm. Often the letter R derived from the word resistance is used instead of the capital omega symbol. Furthermore, the letter R can be used to mark resistors in wiring diagrams. So, for example, instead of 330 ohms, you could write 330R. Instead of 33 kilo ohms, you could write 33K. And instead of 1 mega ohm, you could write M or mega. Another common trick is that if the value contains a decimal point, you can replace it with the appropriate prefix. For example, if the drawing reads 2K2 next to a resistor, it means 2.2 kilo ohm. Let's look at more special resistors.
Léteznek olyan ellenállások,
There are some kind of resistors whose resistance values are not fixed. Their resistance can be adjusted between certain limits. It's important to note that there is a big difference between an adjustable and variable.
változtatható értékű ellenállások például
Adjustable value resistors are the potentiometers, for example. These components' resistance values can be set manually by the user between limited intervals. The resistance of the variable resistor does not depend on the value that the user sets, it varies by the physical impacts on the component.
fizikai behatások függvényében változik.
In the book, we can see three common examples.
A termisztornak hőmérséklet
The resistance of a thermistor changes with temperature, and its marking is very similar to that of a resistor. Of course, the photoresistor changes its resistance in response to the intensity of the light. The marking is also similar, with the two small arrows referring to the light.
a fényre. A nyúlásmérő
As for the strain gauge, I'd like to highlight a special application. If you attach a strain gauge to a body of known rigidity, you can measure the mass of, say, a giant industrial scale.
mondjuk egy óriási ipari mérlegben.
A truck is placed on the industrial scale tray. The scale tray is held in the air by a few small pieces of steel on which strain gauges are attached.
Nyúlásmérő bélyegeket erősítünk. A tömeg
The elongation will be proportional to the mass, and so will the rate of change of resistance, and we can easily measure the resistance with our electronics. So we can measure the mass of the truck. I'll give you some time to think about it.
időt átgondolni.
Let's talk a little bit about another type of resistor, because we will potentially use it a lot later on.
Gyakran fogjuk használni a későbbiekben is.
A potentiometer is most often a component with three electronic leads and a shaft on which you can rotate to adjust the resistance value between each leg.
Állíthatjuk az egyes lábak között mérhető ellenállás értéket. Kiemelném,
I'd like to point out that the relationship between rotation and the change in resistance is linear for most types, but for many types, it's different, for example, logarithmic. So when buying a pot, it's not enough to know its value and physical size, but it's also worth paying attention to its type. It can really trick designers.
meg tudja ezt trükközni a tervezőket. A kapcsolási rajzokon a potenció
In schematics, the potentiometer is symbolized similarly as a normal resistor. The only difference is that the third output of the potentiometer is marked with an arrow. If we use one of the side-along outputs, A or B, and the middle output W of the potentiometer, then we get a resistor with alterable resistance. The length of the conducting track can be changed by the position of the wiper. The potentiometer can be used as a so-called voltage divider as well. If we connect voltage to its outer legs, then the voltage that is measured on its middle leg is proportional to the position of the potentiometer. You can learn more about the voltage divider in the 5th chapter.
az 5. részben tanulhattok bővebben. Azt javaslom, hogy jó
I suggest that we keep a good note of this little creature. It's very ancient and can pop out of unexpected places. It has a great future in the curriculum too.
vár rá a tananyagban is. A szemfülesek már
If you've been paying attention, you have noticed that there are a few fuses on the table in front of us.
kiszűrtünk az asztalon. Ha egy áramkör meghibásod,
If a circuit fails, or it is not used properly by the user, for example by connecting inadequate voltage to it, overcurrent may develop, which can cause the circuit to go wrong, or the wire that provides the power can catch on fire.
vagy a tápfeszültséget szolgáltató vezetékek kigyulladhatnak. Az olvasó
The fuse is connected to the circuit in a serial way, and it heats until melting if the current is bigger than its rated current. Because the fuse itself melts, the conduction is ceased.
maga a biztosító, a vezetés is megszűnik.
After changing of the fuse, our equipment can be functional again, but only if the fault has already disappeared in the circuit.
Továbbra is a hiba forrása. Többféle
Multiple symbols exist to mark the fuse, which are presented on the next figure.
következő ábráján láthatunk. A jelölés
The similarity of the symbol here also indicates that it is a special type of resistor.
szó. Bence,
Bence, did we miss something?
Speaking of it, yes. If we wanted to list all the types of resistors, we would have to write a 100-page book. From those on the table, I'd like to say a few words about this much seen rheostat. It is a power resistance I bring it up as an exotic example. You can guess from the multiple outlets and the slider that it is a high power potentiometer. I use it most often to warm up tests on power supplies for my new circuits. The maximum value I can set it to is 5 ohms, so for example I can test a 5 volt supply initially at 1 amp, then by moving the slider I can reduce the resistance, increase the load. At this rheostat I am allowed to run a maximum of 6.5 amps, so in most cases it serves my needs very well.
We conclude this video with this really practical example. We have more interesting things in store for you. We hope to see you in our next video. Bye!
See you!